Hi, my name is Malcolm and I'm a PSLE Science Specialist here at the Pique Lab. Welcome to another episode of PSLE Science Made Simple. In this video, I'll be analyzing a past year examination question on the topic of matter. I will also include this question to download for free by clicking a link in the description box below. So, let's get started. Question 7. Peter tried to pour milk out from its can without using a can opener. So what he did is that he poked 2 holes on top of the can as shown below. So in part A, they want us to find out why did Peter poke 2 holes instead of 1 hole on top of the can. Now to answer this question, let's see what happens if there is only 1 hole. So if there is only 1 hole poked into the can and you tilt it, now what's going to flow out of the can? I'm sure all of you can tell me there will be milk that is flowing out of the can. But what is the purpose of poking 2 holes then? So to answer this question, let me give you an example. Now let's imagine that we are all in a classroom together, and in this classroom, there is only 1 door. Now when Mr. Malcolm's lesson ends, Mr. Malcolm has students waiting at the other side of the door to enter. But then if there is only 1 door in the classroom, and then my students inside and outside are going to leave and enter the classroom. So do you think they can enter and leave easily? No, it's going to be difficult because the students inside are going to go out while the students outside are trying to come in through the same door. Now this is very similar to the can with only 1 hole. Just like the students trying to leave the classroom, the milk is trying to exit from the can. And just like the students outside who are trying to come in, what else is trying to enter the can? There is actually air that is trying to fight its way into the can. But because there is only 1 hole, do you think the milk is able to flow out quickly or slowly? The milk will flow out slowly. So we can write this down. The milk would flow out slower compared to the can with 2 holes. So now let's see what's going to happen if there are 2 holes instead. So now let me draw it out. So the milk can is going to have 2 holes. And now when I tilt the milk can, what's going to happen? Let's use back the classroom example. So now instead of having just 1 door in my classroom, I'm going to install another door at the opposite end of the classroom. Now when there are 2 doors in the classroom, would the students inside and outside have to enter and leave through the same door? No. In fact, I can tell the students inside to leave through the back door, while the students outside can enter through the front door. In this way, will the students be able to enter and leave the classroom more or less easily? They will be able to enter and leave more easily. So in the same way, this time the milk, we know it can flow out through 1 hole. But this time, does the air need to enter through the same hole as the milk? No, in fact, the air can enter through the other hole instead. And as a result, once the air enters the hole, it is going to push or displace the milk. And as a result, do you think the milk will flow out faster or slower? The milk is going to flow out faster. So let's write this out. The milk flows out faster. So that's why we poke 2 holes on top of the can instead of 1. Now that we understand this, we are ready to write our answer. So let's fill in the blanks together. With 2 holes in the lid of the can, we know that air from the surroundings enters the can through 1 hole, and this is to occupy the what? This is to occupy the space of the milk that is escaping, and is escaping through the other hole. Thus, the milk will be able to flow out faster or slower? The milk will flow out faster. And this is the answer for part A. Next, let's take a look at part B. Now for part B, Brenda wanted to make a water dispenser to wash her hands. So what she did is she's going to pierce a hole on the water bottle as shown in the diagrams below. And they said once the hole was pierced, water at first could not flow out of the bottle. But the moment Brenda loosened the cap slightly, water was able to flow out through the hole. So in part B, she observed that water stopped flowing when Brenda screwed the cap back tightly. And they want us to explain why does this happen. So to understand this, let's take a look at the diagram. So we know that water is only able to flow out of the hole when the bottle cap was loosely capped. Now let's try and understand why. Remember from part A, the milk could only flow out of the can quickly when what was entering the can? When air could enter through the other hole inside the can. So the way this water dispenser works, it works in a very similar way. In order for water to be able to flow out, what must be able to enter? This means that air must be able to enter through the bottle. But how come when the cap is loosely capped, the air can enter? So once the bottle cap is loose, this means that in between the bottle cap and the mouth of the bottle, there is going to be a what? There is going to be a gap. And since there is a gap, this means that air is able to enter through that gap and displace the water, causing the water to flow out. So to answer this question, how come water stopped flowing when the bottle cap was tightly capped as seen in the diagram on the left? So once the cap is tightly screwed on, do you think there is going to be a gap between the cap and the mouth of the bottle? No. So as a result, do you think the air from the surroundings is able to enter the bottle? Answer is no. So with this understanding, we can answer part B. So let's write it out. They said that when Brenda screwed the cap back tightly, air from the surroundings could not enter the mouth of the bottle to occupy what? To occupy space in the bottle, causing the water to stop flowing. So that is the answer for part B. Next, let's take a look at part C. So for part C, they ask, what should Brenda do for water to flow out even faster? So to answer this question, let's recall, what allows the water to flow out in the first place? Water was able to flow out when the cap was loose. And this is because when the cap is loose, what is able to enter the bottle? Air could enter the bottle and displace the water. So if you want the water to flow out faster, that means do you want more air or less air to enter? This time you want more air to enter so that it can displace more water. So what can Brenda do to allow more air to enter? She can simply remove the cap. So that is the answer for part C. And now let's move on to part D. So for part D, they ask what property of matter can be observed from the above experiment. So let's recall, what are the two properties of matter? We know that matter, first one, it has mass. And the second property is that it occupies space. So let's see, from the above experiment, are we able to tell if matter has mass? No, we cannot tell. So this is out. Now what about number 2? Can we tell that matter occupies space from the above experiment? Yes, we can tell that the air has to occupy space in the bottle. So what it did is that the air displaced the water so that it can make space for itself. So number 2 is definitely correct. So that is the answer for part D. We can write matter occupies space. Thank you for watching. I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you guys next time. Bye!